Next is the characteristic reactions of alkenes. The most characteristic reaction of alkenes is the addition of the double bond, which is the carbon-carbon double bond. And in addition, the double bond breaks and bonds to two new atoms or groups of atoms form in its place. For example, we have here this one carbon double bond plus hydrogen chloride. It will resort to hydrochlorinization. It will have single bonds, same as to the others in hydration, bromination, and hydrogenation or the reduction. Next is the reaction mechanism, which is a step-by-step description of how chemical reaction occurs, including the role of the catalyst, if it has a catalyst. And the most common steps in a reaction mechanism are: first, add a proton; second, take a proton away; and lastly, reaction of an electrophile and a nucleophile to form a new covalent bond. For example, this compound here. So we have an acetic acid, which is the proton donor, ammonia, which is the proton acceptor, and the products are acetic ion and ammonium ion. Next is carbocation. A species containing a positively charged carbon atom is called carbocation, or carbon plus cation. Carbocations are classified as primary, secondary, tertiary, depending on the number of carbon groups bonded to the carbon bearing the positive charge. Also, carbocation, a species containing a carbon atom with only 3 bonds to it and bearing a positive charge. Next are the important polymerization reactions of ethylene and substituted ethylenes. Let us define first what is polymerization. Polymerization is the process of bonding together many small monomers into large, high molecular weight polymers. In this example, to show the structure of a polymer, we place parentheses around the repeating monomer unit. This is the repeating monomer unit. The structure of an entire polymer chain can be produced by repeating this enclosed structure in both directions. A subscript N is placed outside the parentheses to indicate that this unit is repeated N times, as illustrated for the conversion of propylene and polypropylene. Now, the most common method of naming a polymer is to attach the prefix poly. Attach the prefix poly to the name of the monomer from which the polymer is synthesized. For example, polyethylene and polystyrene. When the name of the monomer consists of 2 words, for example, monomer vinyl chloride, its name is enclosed in parentheses. So we have here a monomer, which is a vinyl chloride, which undergoes polymerization. We add the prefix poly, and we call it now polyvinyl chloride, or the so-called PVC. Now we have here the polymers derived from ethylene and substituted ethylenes, along with their common names and most important uses. Now we have ethylene propylene, vinyl chloride, 1,1-dichloroethylene, acrylonitrile, tetrafluoroethylene, styrene, ethyl acrylate, methyl methacrylate. The low-density polyethylene, or LDPE. It is the first commercial process for the polymerization of ethylene that used peroxide initiators at 500 degrees Celsius and 1000 atmosphere and yielded a tough, transparent polymer called LDPE. At the molecular level, LDPE chains are highly branched with the result that they do not pack well together and the London dispersion forces between them are weak. LDPE softens and melts at about 115 degrees Celsius, which means that it cannot be used in products that will be exposed to boiling water. Now we have high-density polyethylene or HDPE. In the 1950s, Carl Ziegler of Germany and Giulio Natta of Italy developed an alternative method for the polymerization of alkenes, which does not rely on peroxide initiators. The polyethylene from Ziegler-Natta systems, termed high-density polyethylene, has little chain branching, which we can see here in the example, and consequently its chains pack together more closely than those of LDPE, with the result that the London dispersion forces between chains of HDPE are stronger than those in LDPE. So this is an example of linear polyethylene, which is a high density polyethylene. Note that HDPE has a higher melting point than LDPE and is 3 to 10 times stronger.